again. We'd like to start this webinar and with a brief safety brief as welcome you all for attending and joining this session. We are joined by Professor Christian from France. So he'll introduce himself in a few. So in line with the oil and gas industry briefing, we hope that none of you is driving, and if you are, kindly make sure you come to a complete and safe stop where not obstructing any pedestrians or traffic. We also like to sensitize drivers and users of the road that you ensure that whenever you are driving, you observe the current safety measures. In that, it's currently we are having changing weather conditions, and it's good to ensure that you observe whether you're driving at night and during the day. Also, that ensure that you observe safety emergency response, whereby at the current location, you ensure that you are aware of any emergency exit points and assembly points. Also hope that you are aware of your surroundings and you avoid any distractions as you're listening to the webinar. Apart from that, we have a brief safety mental health brief, whereby we recommend people to ensure that they listen twice, they look twice, and lastly speak once, words that uplift, not only verbally, and also what you send on email or text or even social media. With those few remarks, we'd like to introduce and welcome you all to the webinar for today, which is titled Hydrogen, its place in the energy and ecological transition. This webinar is courtesy of PIEA, School of Petroleum Studies, and also in partnership with TotalEnergies Professours Associate. And for today, our key speaker is Professor Christian GUÉRITTE, and he's going to be able to be speaking shortly. So I think I'll just like to introduce and call upon one of our organizers, Martin Motuma from TotalEnergies, to speak, and then we can be able to proceed. Martin.
Thank you very much, Alfred. I hope I'm audible enough.
Yes, you are.
And good afternoon, everybody. And thank you for attending this webinar. We have the pleasure of welcoming Mr. Christian GUÉRITTE, who is a decorated professor with TotalEnergies Professor Associate, which is an independent non-profit association which is supported by TotalEnergies Foundation. The TPA, as we fondly call it, boasts of more than 250 member professors, most of whom are still working with TotalEnergies, and some are already retired from TotalEnergies, and they deliver lectures worldwide, to promote the world of energy and relations between universities, schools, colleges, and of course industry through technical, economic, scientific, legal, and marketing presentations. So they are all expert professors, and Professor Christian, I'm sure he will also say a few words about himself, is a highly experienced engineer with a background in mechanical engineering and petroleum economics. He started his career before most of you were born in 1975 in the exploration and production division of TotalEnergies, and he's advanced through many roles. And before his retirement, I think he worked as the head of economics. He's worked as a managing director in Russia. He's also been involved in major projects in France, I think you tell us, and the Netherlands, and he joined the TPA in 2010. So, Professor, if you do not mind, I know your CV is very long. I would like to invite you now to just compress it in a few words and take this up. Welcome, Professor Christian.
Thank you very much. So I think you said almost all what had to be said regarding my career, but just to sum up, yes, I am. My background is engineer and economist, and I started as an economist in Total Exploration and Production. It was many years ago. As you mentioned, I joined the group Total Group in 75. At that time, you see, you had three oil and gas company in Europe. You had Total, you had Elf, and you had Petrofina in Belgium. And in 2000, thanks to the president at that time, Mr. Thierry Desmarais, Total became TotalEnergies, regrouping the three most important oil and gas company in Europe. So TotalEnergies now is really one of the top 5 majors in the energy sector. My career was mainly at the end done in the framework of negotiation and general management of affiliates of Total. When I was in charge of negotiation in the group, I had the chance to travel in many countries, and in order to build up new business development with foreign administration, foreign government, and ministers of oil and gas in many other countries. And my two last position were position of general management. First one in LAC in France, where I was responsible from 2000 to 2004, just after the merger between Total, Elf in particular. I was responsible for this plant, which was one of the most important gas plant in France at that time. And my last position after that responsibility in LAC was general manager of the Dutch affiliate of the group in the Netherlands. At that time, from 2004 to 2010, this affiliate was the second company in the Netherlands for gas production, mainly a lot of medium-sized gas field offshore. And obviously, these positions were for me very interesting. And since 2010, as you mentioned, I am a member of TPA, and I continue to travel quite a bit in foreign countries to deliver courses of the world of energy in the global economy. That's it. So, can we start, Alfred?
Yes, we can start.
Okay, maybe I will share my presentation. I will share my presentation. Alors, où est-ce que je l'ai? Voilà, c'est ça. Can you see it?
Yes, we can see it.
Okay, I put it full screen.
Okay, yes.
How can I delete that? Trying to put it full screen, but there is a window that I'm trying to delete. Okay. Is it okay?
Yes.
Okay,
Yes,
good.
Prof.
So as you mentioned, the subject today is hydrogen, which is a rather complex subject. Its place in the energy and ecological transition. So I use the same title as the one you delivered to your all the participants. So we will first of all present hydrogen and its various facets with specific data. So hydrogen, I'm sure you know the basic characteristic of this interesting product of the Mendeleev table. Is the first and lightest element of the Mendeleev periodic table, with one proton and one neutron in the nucleus of this element. It is the most present element in the universe, 75% by mass and 90% by number of atoms. It's present in very, very large quantities in stars, in gaseous planets, in nebulae, interstellar gas. And in fact, hydrogen clouds are the basis of the star formation process. It represents 3/4 of the mass of the sun. And you know probably that the physical and chemical reaction which is taking place in the sun is a reaction of fusion. I will say some word about it. So if you put together one atom of hydrogen, you end up with a dihydrogen, H2, which is the molecule which we know very well and which is taking an important role in the life. The density are precise here. What is important to understand is that obviously hydrogen is in a gaseous state in a normal condition of temperature and pressure. But from time to time, we can use it as a liquid, and hydrogen can become liquid at a temperature of minus 255 degrees Celsius. Minus 253 degrees Celsius. It's very explosive, and in the normal condition, the H2 molecule is a colorless, odorless, and highly combustible gas. There are three isotopes of hydrogen. The 1H, called also protium, is the most common isotope we can find in nature. Hydrogen 2H is a deuterium, which is rare. Hydrogen 3H is a tritium. It is very rare. And you probably know that deuterium and tritium are the two main elements which are used in a nuclear fusion reaction, where in fact you mixed two lights atoms, two lights nucleus, deuterium and tritium, to end up with a molecule of helium, which supply of a huge quantity of energy, and that is actually what is happening in a nuclear fusion reaction. H2 represent it's a very, very limited quantity in the atmosphere. If you remember, last 1 week ago when I presented the subject of the end of carbon, I mentioned we talked about CO2 emission in the atmosphere, and you may remember that the CO2 content in the atmosphere is also very, very low. But it's still 420 ppm today. So you can see that H2 is even much rare in the atmosphere of the Earth, 0.55 ppm. On Earth, water is the most common source of hydrogen, composed of, water is H2O, the chemical formula H2O. And water covers, just to remember some data, 72% of the Earth's surface. And the volume of the sea and oceans is obviously estimated at a very large quantity of cubic meter, 1.4 trillion cubic meter. Why do we call it hydrogen? Because most of the hydrogen in the world exists in molecular form, such as an organic compound, methane, coal. We can find this hydrogen molecule in CH4 for the methane, in the coal formula also, or in water, as we said before. And in fact, it is why we have the word, the prefix hydro in the word of hydrogen. It represents also about 8% of the human weight. And it is highly energetic. With about 40 kilowatt hour per kilo for the high heating value, and 33 for the low heating value. You know the difference of these two values correspond to the latent heat of vaporization. It is very inflammable, as you can see here, much more than an air-methane mixture, but air-hydrogen mixture is very much flammable. It is one of the reasons it is very dangerous to manipulate hydrogen without safety precautions. This table summarizes all the technical and specific and chemical characteristics, so I will not go into this detail because I mentioned the most important element that should be kept in mind before. So, what are the fundamentals of the nuclear hydrogen in nature? In fact, in nature, you have two major sources of hydrogen. The most important one, and that has to be clear today, is coming from hydrocarbons through steam reforming or other processes. And you can see the formula on the slide here. But I will go later in a few detail about it. So when you mix CH4 with water at high temperature and pressure, we end up with H2 and CO2. The second major source is water, as we said before, and we can produce hydrogen through electrolysis in water. I don't remember. Maybe you see, when I was a child at the college, we could have some experience taking a small battery, and with the two electrodes in water, in a glass of water, you put two electrodes in a glass of water, and you can see some bubbles emerging, and these bubbles represent, in fact, the phenomena of electrolysis, where you can end up with the production of oxygen and hydrogen through this very simple experience. But we will see later that electrolysis is not a so easy process. To get hydrogen needs an important quantity of electricity. We'll see that also later, and in particular, we are also making here some promotion of nuclear reactor. They can supply electricity and heat to produce hydrogen in a rather important quantity. What is also important to mention is that hydrogen is a poor energy vector. Why? Because its transportation costs are very expensive, very expensive. Because the product is rather dangerous, and it's 10 times, represent 10 times the one of liquid hydrocarbon per unit of energy. It's also a poor medium for storage in mobile system. We'll see that in the transport sector later also. You have, generally speaking, in mobile system currently 5% of H2 mass versus 95% for the containment system in the case of ground transportation. Some additional information regarding the industry of hydrogen today. You see, to produce hydrogen as an energy vector, in fact, the logic would be to attach carbon atoms to create hydrocarbon molecules, because hydrocarbon molecules are very practical in their normal usage. They are efficient energy vectors, and they do not raise any problem for storage, for mobile application. And we will enter into more detail about this when we'll talk about the various fuels which are necessary for the transport sector. The production of hydrogen, as we said before, can also be made through electrolysis. When you produce hydrogen with electrolysis, there is no CO2 emission, obviously, because the only product you can get is water. So let's start with general comments regarding one specific use for hydrogen mobility, which can consist in the fuel cell electric vehicle, fuel cell. Again, we will enter into more detail later about it. First of all, today, worldwide, in 2023, we have in the world about 97,000 running fuel cell electric vehicles. 87,000. There were 11,000 6 years earlier. But you can see that this number is still very, very, very low compared to the totality of the vehicles, light vehicles we have in the world. And it is a figure that you should keep in mind. You see, in the world today, we have a bit more than 8 billion inhabitants in the world, and we have 1.3 billion light vehicles in 2023. So the modern type of vehicles in connection with the energy transition for the time being are very, very small compared to the totality of light vehicles in the world, which are running with thermic engine. With the fuel cell electric vehicle, you need obviously hydrogen refueling station, because you have to be supplied with hydrogen, and you have to get access to hydrogen. And today, in 2023, we have in the world 1,100 existing hydrogen refueling stations. But this activity and this sector is growing rapidly, even at a small scale compared to the overall industry in the world. And additional sales of fuel cell electric vehicles and construction of hydrogen refueling stations are planned in many countries in the world. I will say some words on the Hydrogen Council, which was established on 2017. And obviously, one of the challenges that all the manufacturers of and the use of hydrogen is involved with concerns the future deployment and the cost, because today the costs are rather high to develop this technology. Let's have a look now at the industrial use and demand worldwide for hydrogen. So the potentialities obviously are very important. You have here a small sketch regarding the demand and supply of hydrogen, the various potentialities. So in terms of supply, as we said before, and we will go into more detail later about it, hydrogen can be supplied with sources of, I would say, fossil energy, coal, natural gas, and can be also produced with electrolysis, as we mentioned before. And regarding the demand, you have several aspects for the demand. Hydrogen is needed for industry, for building, for transportation, and in particular, in terms of mobility, hydrogen can be a source, is an important source of energy for the fuel cell electric vehicles. Another way of illustrating this is the various sectors which can use hydrogen as an important product. So in the refining industry, it's used to defuelserize the fuels because fossil energy contain, generally speaking, important quantity of sulfur, so that has to be eliminated. And hydrogen is used for the fuel desulfurization in refineries. It's used also in the printed circuit because you need hydrogen peroxide to manufacture printed circuit. It's the chemical industry for the synthesis of plastic. Another very important use of hydrogen, and you probably know that, is the production of ammonia for the fertilizer industry. And I will say some word about the link between ammonia and hydrogen, which is rather important in the development of industrial activity for the next decades to come. And in the glass industry, it's used as a heat source. So many industrial use of hydrogen, as you can see here. The global demand for hydrogen, you have here a picture of the situation in the last decades. And you can see that the two main important use for hydrogen with regular growth. You can see that from 1975 until the year 2018, it's an illustration of what occurred in the past years. The growth is regular. The growth is regular. And we can say that the split of the demand for hydrogen is mainly for refining industry, it is a light blue here, and for ammonia, mainly for the fertilizer industry. So what is the situation, the more recent situation, and what are the perspectives for the next years to come? You have here the illustration of the last analysis, the most recent analysis made by International Energy Agency in their Global Hydrogen Review, which was published, you see, very recently in October 2024, which is a good synthesis of the situation today and some perspective. So if we are looking at the hydrogen use by sector from 2019 to now, you can see that we are the growth was a bit less important than before, but what is important to keep in mind is that in the 2023, the global demand for hydrogen was 97 million tons of hydrogen. 97 million tons of hydrogen. Which was mainly used for industry and refining. And if we are looking at the perspective for the next decades to come, in particular looking at the so-called net zero emission scenario, I believe that 1 week ago, when I presented the very scenario of international agency, I precise what is the net zero emission scenario. Net zero emission scenario is the scenario whereby we end up with a net zero emission for CO2 in the year 2050. I think we discussed the fact that this scenario was the probability to have this scenario is very, very low because it needs a lot of efforts and modification of the mix energetic for the next decades to come. So it's a probability to end up with this scenario, which should correspond to an increase of temperature of 1.5 degree in year 2100 compared to the pre-industrial period. This scenario is probability of success is very low, very low. Anyway, you can see that in this scenario, in the year 2030, we have a different vision of the split of hydrogen use, where in the blue part here represents the new possibilities to generate and to use hydrogen, and mainly we're talking here about the low emission production of hydrogen, in particular electrolysis. The situation by region is illustrated on the right-hand side diagram here, Camembert, where China is again very important in terms of use of hydrogen, and also North America. Middle East is the number 3. So you see the 97 million tons of H2 are splitted into mainly industry and refining, and we have here the split between both. So for refineries, in 2023, the demand was about 43 million tons of H2, splitted this way regarding the region used by region, and source of hydrogen by type of source of hydrogen. Just a comment, when you are looking at this denomination here, fossil and with CCA US, I will present just after the low emission hydrogen production, where we will talk about CCUS, carbon capture and utilization, storage and utilization, which is a way to reduce the emission of CO2 when we produce hydrogen. If we are looking now at the hydrogen demand and source for industry, we have 54 million tons of hydrogen out of the 97 global production for 2003, which is illustrated here. And if you look at on this graph here, on the red bullet point here, you can see that, in fact, talking about share of low emission, until now, hydrogen production was due to the use of was mainly due to the use of fossil energy with important emission of CO2. But you can see that in a net zero emission scenario in 2030, we should end up with 25% of use of low emission hydrogen production. So let's talk about production now. We presented the demand. Now let's have a look at the hydrogen production. So this table, which is deriving from a report from AFP New Energy, French Institute of Petroleum. Again, you have the three main sector for the production of hydrogen. First one is reforming and CCS with CCS. Second one is electrolysis, and the third one is gasification of biomass, which can generate hydrogen. You have also an item called here natural hydrogen, because we can find hydrogen, sources of hydrogen in the earth. I will say some word about it, but for the time being, this is something which will contribute at a very, very low stage for the production of hydrogen. And regarding the conversion, you can sell directly hydrogen to industry. We can mix hydrogen with natural gas, which is called methanation, and to end up with gas. We can use hydrogen, as mentioned before, to run fuel cell or turbines. Here we are talking about power to hydrogen to power. And we can also imagine to use directly hydrogen in engine for vehicle. In such a case, hydrogen is used directly as a fuel, and in an internal combustion engine, you use hydrogen instead of gasoline and diesel, but this technology, for the time being, is really at the beginning of their development. What is the situation for the year 2023? As mentioned before, mainly hydrogen today production is coming from refineries, and to do that we have used in 2023 6% of global natural gas and 2% of global coal. 99% of H2 production today come from unabated fossil fuel. What does it mean? Unabated fossil fuel means that we are using fossil fuel as they are produced directly from the coal mines and hydrocarbons reservoirs. To the contrary of fossil fuel with CCUS, carbon capture, utilization and storage. I recall you that this technology consists in capturing the CO2 which is emitted from the burning of fossil fuels, and to store the CO2 or to use it for enhanced recovery of oil and gas in certain projects. In such a case, you decrease drastically the CO2 emission in the atmosphere. Electrolysis count for nothing almost in the year 2023. Okay. When we talk about H2 production, we are talking also about CO2 emission, and the CO2 emission of H2 production highly depends on the fuel and technology which is used. So you find here again the 97 million tons of hydrogen produced in 2023. You see it's in fact 2.5% versus previous year. And this production is responsible for emission of about 1.3 billion tons of CO2 equivalent. 1.3 billion tons of CO2 equivalent. And maybe you can keep in mind the fact that in the year 2023, the world has emitted globally 35 billion tons of CO2 altogether. So the hydrogen production contribute a little bit to these emissions of CO2. And the challenge, obviously, if we are willing to continue to use hydrogen as a fuel for a certain utilization in the industry and the transport sector, we should avoid to emit important quantities of CO2. This is why electrolysis is a technology which has to be developed. You may know that when we talk about hydrogen, we talk about some different colors for hydrogen, and on this slide I just sum up the four most important way of producing hydrogen with their corresponding terminology. So what do we call green hydrogen? Green hydrogen is produced by electrolysis of water. In such a case, you do not emit any CO2 on the condition that electricity which is used is coming from renewable energy or nuclear energy. If you use electricity which is coming from a coal-fired plant, obviously we are not in the correct way. Okay, so green hydrogen is produced by electrolysis of water by decarbonated source of electricity. Blue hydrogen is produced from fossil fuel, but with a CCS technology attached to it. So we are still talking about production of hydrogen from fossil fuel, and in particular natural gas, but emissions are dealt with using CCS technology. So you reduce, in such a case, CO2 emission in atmosphere. Gray hydrogen is produced from natural gas through steam reforming, which is what is happening essentially in the current period. I will detail that in a few moments. And brown hydrogen is produced from gasification of coal, which is a technology where you produce coal in mines, and through a Fischer-Tropsch process, which is well known, which has been well known for many decades. The coal is gasified; it's transformed into gas, and the gas can be used for fuel and various different usages. Brown hydrogen is produced from gasification of coal. The production by technology is a sum up on this diagram, also coming from the most recent report from International Energy Agency, and you can see that today mainly it's in natural gas which is used to produce hydrogen in a steam reforming technology, followed by coal, and followed by byproduct, which originate from refineries and petrochemical industry, from processes like naphtha reforming, and so on and so forth. In terms of region for the production, you can see that China is important, Middle East is important. We are talking about industrial countries dealing with an important petrochemical activity and also oil and gas production. United States also are important. You have India, you have Europe here, etc., etc. So if we are looking to look at some scenarios for the future, this slide is interesting because you have an image of what could be envisioned for the future According to the International Energy Agency scenarios, which have been presented recently in their report for 2024. So we start by this situation in 2023, where we have 97 million tons of H2 which is produced. And you can see that obviously the scenarios are completely different. I mean, the perspective of hydrogen production is completely different according to the various scenarios. If we are looking at the APS scenario, which is, I would say, the scenario which could serve as a reference for the next years to come, and corresponding to the commitments made by all the countries in the world following the recent conference of the party, you can see that the use of coal and gas will be less important, but in 2050, the part of the electricity, that is to say electrolysis for production of hydrogen, will be more and more important. Okay, and for the net zero emission scenario, it's even more characteristic. So in all scenarios, in fact, the future of hydrogen seems quite interesting. The question is, with which probability this various scenario will be developed in the next decades to come. Because behind this, you have also a question of feasibility and a question of cost to develop these technologies. Alors, let's enter into more detail today about the process of in refineries with the steam methane reforming. In fact, again, this technology is the one which is operating today at a great scale. So you have two steps. First of all, the raw material is methane, CH4, that you can see here, and it's mixed with water vapor, water at a high temperature, and that gives carbon oxide plus hydrogen. This is the first step. The second step is then you treat again the carbon oxide with H2O. It's a water gas shift reaction, and we end up with CO2 and H2. So at the end of the day, you use CH4 as the raw material for this process, and you end up with hydrogen and CO2 emission. This is what is existing today. A small word about natural hydrogen. You can find hydrogen field, so to be compared with oil and gas field, but it's not very practical to produce today. I will not spend too much time to present it, but in fact you can find the hydrogen. The generation of this natural hydrogen is not really well understood today, because you can find it due to oxidation or reduced iron in the subsoil. You have some deposits of hydrogen which have been recently discovered in Mali, in Russia, in United States. But this natural hydrogen is more today geological curiosity than an industrial resource. Okay, so you have some elements giving more details about the various potential source of natural hydrogen which are illustrated here. I will not comment it because it's not really what that will change the picture in terms of hydrogen use in the future. Transportation and trade. To transport hydrogen, you need a pipeline. And obviously, transportation of hydrogen is an operation which has been to be clearly well controlled in terms of safety. But hydrogen trade is a fact today. You have here an illustration of what is existing in terms of hydrogen pipeline in the year 2023. For instance, in Europe, you have 1,500 kilometers of hydrogen pipeline in Europe, and also in North America. It's quite important. And you can see that you have new projects which are planned to extend this network. A zoom on the map regarding hydrogen pipeline in Europe. Clean hydrogen and low emission hydrogen. Again, I mentioned this before. When we talk about low emission hydrogen, we talk about both renewables, hydrogen produced with electrolysis, which do not produce any CO2 in the atmosphere, and fossil fuel with CCUS, as mentioned before. Electrolyzer project, you need to obviously to install a new electrolyzer. You have here a picture of the evolution of electrolyzer installed capacity in the world, and you can see that this growth is quite important, with in 2024 an expectation to have a bit more than 5 gigawatts of capacity installed for electrolyzer. I will not comment the other curve. You will have access to the document. And a picture on the low emission hydrogen production review globally for production and also for electrolyzer project. So you can see that mainly the activity is important in a country in Europe, and also in China, and also in America. Electrolysis, you know probably the principle, which consists in splitting H2O into H2 and oxygen. This reaction takes place in the electrolyzer. And what is important to understand also is you need a large quantity of energy, electric energy, to produce 1 kilo of hydrogen. Globally, 55 kilowatt hours are necessary to produce 1 kilo of hydrogen. So this is another way to illustrate the fabrication of hydrogen through electrolysis. Obviously, to get green hydrogen, as mentioned before, you should use a decarbonated source of energy, mainly renewable energy or nuclear energy. Hydrogen, one important way of using hydrogen is for mobility, and let's have a look on it. So you have important possibilities for the transport. You have some picture here. And for the transport sector, two factors are of importance. You have the fuel energy density, volume and mass, and the compactness of the storage system. If you are looking at the fuel gross energy density, we can see that you see hydrogen is rather energetic. We can compare various technology when you talk about H2 as a gas or H2 as a liquid. But you can make a kind of ranking regarding the performance of the various fuel for transport in terms of gross energy density. But what is also important is to look at this fuel gross energy density, including the storage system in terms of volume and mass, because you can imagine that when you use a normal car, fed by gasoline or diesel, the weight and the volume of the tank is not very important, while to transport hydrogen or compressed gas, it's another story, and you need to have much heavier and solid tank to contain the fuel. And globally, you see the best compactness, energy compactness for the transport sector is still liquid hydrocarbons, while for hydrogen, batteries, hybrids, and compressed natural gas, the compactness is much more important, which diminished quite a lot the energy density in terms of kilo, and of mass and volume. So the challenge of the transport industry is to increase the energy density, to reduce storage system volume and weight, and to reduce the cost. Not to speak about expanding massively refueling station and to use decarbonized source of electricity production. So for the transport system, I think I have to go a bit fast now. You have two ways for the transport system. First one is to use hydrogen in the internal combustion engine, or to use a fuel cell electric vehicle. Well, this is a scheme which summarized the various cycles for both technologies. If we are looking at hydrogen use in transport, you see for the transport sector, the use of hydrogen in terms of kiloton is about 60 kiloton in year 2023. One of the most important use for hydrogen for transport should be more dedicated to trucks, demanding long haul. And this is the idea of the manufacturers and also the vision of TotalEnergies. Hydrogen can be used also for again for trucks. It is a vision by Renault, and you can define the borderline between the use of hydrogen and battery, depending upon the distance which have to be run by the various trucks. Low carbon fuel, a word about it. Low carbon fuel are artificial fuel which result from the synthesis of using CO2, combining CO2 with other molecules, which can lead to the production of low carbon fuel, which can be used directly, like diesel and gasoline, in tanks of vehicles. So low carbon fuels also can be used for marine. And if we are looking at the global energy demand for transport by the various scenarios of International Energy Agency, you can see here on this slide that oil, which is mainly used for transport today, will normally diminish and leaves the room for electricity and hydrogen. But hydrogen will still have a rather small part of in the picture. Fuel cell, this is I think I have to go a bit fast now. Principle of a fuel cell. So you have several pictures here showing the principle of the fuel cell with some example used by certain manufacturers. This is the Hyundai Nexo car. Obviously, all these cars, the price is very expensive, and it's not used very extensively by the people, obviously. This is an example of a bus run by hydrogen in the Po region in France, which experienced also some difficulties at the beginning. The efficiency ratio, compare efficiency ratio between hydrogen as a direct fuel for internal combustion engine and a fuel cell. You can see is very different. Fuel cell energy efficiency is greater than direct use of hydrogen as a fuel in internal combustion engine. And if we are looking at the overall efficiency ratio for a fuel cell from the supply of electricity to the end power of electricity supply at the wheel for the car, you can see here that the global efficiency ratio is not very important. It's about 22%. But the advantage of this, again, of this technology is that you do not emit, I would say, 1 gram of CO2 in the atmosphere. You only produce H2O. So I will go rather fast here. I have also here presented some example of typical models and prototype with different technology for the cars. What has to be kept in mind is that regarding the transport sector, the fuel cell technology is much more popular today than the direct use of hydrogen as a fuel, because this technology of using direct hydrogen, the direct fuel in internal combustion engine is more, we know more prototype than commercialized vehicles today in the world. Okay, let's have some words about ammonia and hydrogen. Ammonia is a carbon-free fuel and suitable for use in various sectors, obviously in fertilizer. And ammonia can serve as a hydrogen carrier. It's more easy to use. You have a number of pipelines for ammonia existing in the world. There are less problems regarding safety, and ammonia can be used actually as a good hydrogen carrier. It is important to mention that. Ammonia can be produced by mixing hydrogen and nitrogen through an exothermic reaction. And at the end of the day, we can also then, from ammonia, transform ammonia into hydrogen and nitrogen through an endothermic reaction. So ammonia can also generate hydrogen. This is a value chain for ammonia and hydrogen. And ammonia can be used in a marine sector, and also continue to be served, obviously, as an important raw material for fertilizing industry. I just mentioned here a project in Morocco, which recently has been developed by TotalEnergies to develop an important project of ammonia production and hydrogen production in Morocco. Maybe you heard about it. And it is probable that ammonia demand, thanks to all the advantages I mentioned before, will develop in the next decades to come. You can see the traditional ammonia industry will continue, should continue to grow slightly, while in the hydrogen economic model, where we understand we can produce hydrogen through ammonia, which can be characterized by an important source of energy. This can grow quite rapidly until the year 2050. The cost, very briefly, I will not go into detail about it, but you can have access to the documentation. The cost of hydrogen in terms of supply of the raw material is not really much more expensive than when you buy gasoline or diesel in a service station. But on the other hand, what is increasing the cost, the overall cost of the chain is the electrolysis problem, the electrolysis process, and also the transportation cost of hydrogen and the electrolyzer cost of to produce hydrogen has an important effect on the overall economics of the chain. This is the reason why today the fuel cell vehicles are very much expensive compared to the normal internal engine cars. And also because due to the fact that you need in this technology, you need specific storage tank power enough to support hydrogen at a pressure of 700 bars or 350 bars. And I would like to terminate on what is going on in Kenya, in fact, because Kenya has a strategy to develop hydrogen. So if you permit me, I will present to you some documentation coming from the Ministry of Energy and Petroleum, where reminding that 1 year ago, Kenya launched a green hydrogen strategy and a roadmap, which is illustrated here. Kenya, alors, it's a quite a technology which is rather new and not evident and to put in place and to develop, especially in certain countries. But in Kenya, the advantage of Kenya is that Kenya is using renewable energy in the energy mix with an important share. Biomass and also geothermal is important, and also hydroelectricity is important. So there are some advantages on this aspect, but still I would say the project is a long-term project, and it will not be done very easily due to the technical difficulties that I presented before regarding the production of green hydrogen for the next decades to come. So I think, Alfred, that I terminate here my presentation. And the conclusion, just reminding the conclusion with the launching of Hydrogen Council in year 2017, and you can see Mr. President of Total, Mr. PIEA, who is here. And hydrogen as with a lot of potential participants for companies and organizations which support this Hydrogen Council. Since 2017, some projects have emerged, more or less. And there is another forum which exists also worldwide for the promotion of clean energy and hydrogen, which is a clean energy ministerial, advancing clean energy together. So just to conclude that hydrogen is still a subject of great interest by the industry in general, but time should be a bit long to end up with operational and safe conclusion for especially for mobility. And probably even if hydrogen is a very nice product to generate, to contribute to energy transition, the use of hydrogen should remain rather limited in the world of energy of today. Alfred, this terminate the presentation, and I'm ready to respond to questions.
Okay, thank you. Thank you, Prof, for the detailed presentation. We have a few questions which maybe you can answer. One is, how does hydrogen compare to other renewable energy solutions in terms of efficiency and feasibility of large-scale implementation?
Okay, like I mentioned, hydrogen, we can see that the most important source of use would be transportation system. So you have several for the transport sector. You have several possibilities. Huh? You have obviously the most important possibility today is the traditional use of gasoline, internal combustion engine with gasoline and diesel. Remember that today we have 1.3 billion cars, light vehicles in the world. This quantity should increase in the next years to come, obviously. But you cannot transform within 10 years' time the technology to run these vehicles and to go from gasoline and diesel to electric and fuel cell vehicle. So what is much more popular today in terms of mobility, clearly, is the electrical motors, the electric vehicle, hybrid vehicle, where you combine the running of the car with traditional fuel and also electric battery. So this will take more and more importance in the next years to come, because technical progress has been made recently to reduce the cost for the batteries. You have certain countries in Europe, in particular the Scandinavian country, where you have a majority of cars which are run now with batteries. Okay, so in my view, this is the technology which will be more and more important to be developed in the future. Hydrogen, as we mentioned before, is a bit more tricky. It's a bit more difficult to put in place because you need again a specific characteristic for the tank to produce, to transport hydrogen in the vehicle. You need very strong very strong tanks with a weight which is much more important than the traditional weight for tanks for internal engine car, for instance. So hydrogen again should be developed, but at a much lower scale than the batteries, for instance. On the other hand, hydrogen could be used more efficiently for the shipping transport, and also for the aviation in the next decades to come.
Okay, that is well understood. The last question is, what is the current state of hydrogen consumption in Kenya?
What is the
current state of hydrogen consumption in Kenya?
I think you should. I think the current stage of consumption of hydrogen in Kenya is very, very, very low, no? What do you think about it?
I think it's still in the adaptation stage. So I think maybe in the coming years.
Sure.
Yeah,
No, but I think Kenya government has built up this strategical program. It's very new, huh? It's very new. For the time being, in terms of energy mix, Kenya use biomass. Let me see. I have Can you see can you see the slide?
Yes, we
Yeah.
can see it.
Yeah. Kenya is an interesting, I would say, is a very good country, I would say, in terms of renewable energy, because Kenya, in terms of primary energy mixed, use 61% of biomass and waste, which is biomass is a renewable energy, that is clear, and solar and wind at the level of 18%. So it's a good performance, I would say, in terms of renewable energy. What is also very interesting to note in Kenya is the fact that electricity represents a very low part of the final consumption, 5%. But electricity is coming mainly from also the renewable energy with geothermal. Kenya is very well positioned in terms of geothermal activity compared to the other countries in the world. It's the first one in Africa, I believe, in terms of geothermal energy. And also you have hydroelectricity and wind energy, which are used, I would say, at a great scale to produce electricity. So Kenya is well positioned in terms, in my view, in terms of renewable energy development. But hydrogen is peanuts. I mean, today. But you should know better than that this than me, Alfred. Hello.
Hello, yes, I can hear you. Yes, so as far as hydrogen is concerned, I can say there's a road strategy roadmap on the same from the Ministry of Energy and Petroleum. And I think it's between now, they're currently coming up with the relevant evaluation plans, coordination committees on the same, and also how to implement it and into the national energy policy. So it's a work in progress in Kenya.
Yeah, but just a personal comment. You see, maybe the country should set up the right priorities in terms of development of renewable energy, and it's good that. The strategy regarding potential development of hydrogen is developed. But maybe there are some other aspects that should be given also a priority to develop more traditional way of renewable energy in the country, if you see what I mean, because hydrogen is something which is obviously is a technology which is not easy to develop, I would say, economically speaking, and on the right way, especially in the transport sector.
Okay, that is well noted. I'm seeing hand raised, Wanjiko, the PIEA General Manager. Yeah.
Yeah, thanks, Alfred, and thank you so much, Professor Christian. Pleasure listening to you again. And I would agree with you. I just wanted to chime in a little bit on the renewable status and renewable energy status. And you're very right in saying that, as we plan out our transition, our energy transition roadmap and policy, and we have requested for an energy transition policy, standalone policy. However, it would appear that the ministry would be more comfortable having the transition subject matter entrenched in the petroleum policy, which is still an ongoing work, which has been hived off from the National Energy and Petroleum Policy of 2015, but of course with renewed information and priorities. So on matters renewables, first is that indeed we as a country, and I think also as an industry, we are actually pushing for focus on the low-hanging fruit. And the low-hanging fruit, I think we discussed in the other session, is really the solar, wind, and geothermal. Even before the nuclear and the hydrogen, because then what we have doesn't require what I would call a lot of rocket science. And in terms of investments, there's already work going towards that direction. And even in terms of utilization and the benefits that accrue from solar, wind, which are really, really still untapped to the potential that we have in this country. And you have seen, and you're right in terms of what we've done with geothermal and where it has placed us in the continent. And in fact, we are providing a technical expertise on geothermal as a renewable to other countries within Africa. I think Malawi is the latest one, if I'm not wrong.
Okay.
So I would agree. Yeah, on the energy mix, just there's a pie chart I think you'd put on the energy mix, the general energy mix, the bit on firewood, not firewood, what is it called? On there's a pie chart you had put on the energy mix. Do you mind just broadcasting that again, where we have 61% for
Biomass.
biomass?
Yes.
Yes,
Biomass. Yes.
yes.
Biomass and
Just
waste.
to
Yes.
right, yeah, just to note that is mainly going to cooking. I think you've taken the one that is
Okay.
global.
Mm-hmm. Mm-hmm.
Yeah, and which the government has a policy, of course, aided a lot by private sector, to displace the biomass for cooking with cleaner sources of cooking because of the impact of not just health, which is the primary one, but also the impact on biodiversity degradation, and specifically on deforestation. So that's
Okay.
61% is
Mm.
more representative of the use of biomass in cooking, which there's a whole strategy in reducing that to perhaps the biomass just being used for other renewable energy utility, but not as a primary cooking fuel, because
Okay.
again of the impact that has.
Okay.
Yes, just to chime in on that. Thank you very much.
It can be used also to generate electricity. Huh?
Absolutely, 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 indeed, absolutely.
Thank you very much for this explanation. I appreciate.
Yeah, thank you. So I'd like to take this opportunity just to open the microphones for anyone who may be on the call, who may want to maybe just talk or maybe place their question. So I'm just going to open the mics in the next few seconds. So once the mics are open, we'll just use the raise hand feature to ask the question, and then from there we'll be able to close from there.
You
So
can
just a
you
moment.
can deliver, Alfred, the documentation to all the participants.
Yes, I will.
Mungai Miriam has her hand up.
Yes, Miriam, just a moment. Yeah, I think the mics are on now. All that and is. Yes, Miriam. Yes, Miriam, you can unmute your mic. Miriam, you can unmute your mic.
Alfred, Miriam has typed that the mic is still muted.
Okay.
Now it's okay. Can you hear me?
Yes.
Yes, we can hear you.
Great. It was still on mute mode. Good afternoon, and thank you very much, Dr. Christian, for this very elaborate presentation. So I'm from Bamburi, and my question is Bamburi Cement, and we are very big in biomass. We are very big in now onboarding solar technology. But I want to, as this is the next frontier, hydrogen, and I see that the government has put already a roadmap and a strategy for this. This is a question for the involvement of private sector. I've not seen this very opened up for contribution by private sector, probably through joint working groups, so that we can also participate and give views in the roadmap. Is there opportunity for that? That is my question, because it is a really important area where private sector, especially those in manufacturing, are playing, and this would give us we could walk the journey together.
Yeah, again, I think that this roadmap, which has been defined by the Kenyan government, is very young, is very recent. So there is a program to be satisfied, to be defined, and to be satisfied, and it is clear. The question is very important, because to develop this roadmap regarding the development of hydrogen technology in Kenya, you need money. It means to have important to develop important investment, to finance important investment, and it is clear that the government cannot do it in itself, and you should try to find private financing, and that is a challenge. So the financing can come from private companies in Kenya, can also come from external company, and it is a challenge because this program can be developed only if you have behind money to finance installations, to finance the development of this technology. And as we have seen before, the hydrogen technology is not very cheap. You should spend quite a lot of money. If you permit me, I can give you some comment coming from a recent experience. You see, 2 months ago, I delivered a course also in University of Namibia in Kitmanship. And when I was in this country, in Kitmanship, I read the newspaper. I don't know if it was maybe Africa Today. And I see that, I see that European Union, they have given a financing of maybe, if I remember well, 20 million euro to Namibia to precisely develop hydrogen technology. And I was very much amazed by this, because frankly, I think that Namibia, they should have more priority than to develop hydrogen. Just a personal comment, you see.
Okay. Wanjiku?
Yes, thank you. And thanks, Christian. I think you've nailed it. My comment to Miriam, I'm not sure which whether you're from the conventional oil and gas sector or you're coming from a different one, because this is a broad invitation list.
I'm coming from cement.
You're coming from cement, yeah.
Yes.
So what I would, from experience and from my experience here at the Industry Association, and actually a representative of what the oil and gas has done in terms of its approach to making its voice heard, is to ensure that you're very proactive. Government will not come to you on certain matters because it's assumed that you do know. And now you know, because of this platform that has been provided through the PIEA and one of its key members, Total, and obviously we have an expert who's in the room. So of course, what you've picked from here is what you will use to then craft your professional and technical input for the government's proposal with respect to hydrogen. So rule of thumb, please, proactivity is very, very important. You can do it as a company or through an industry association, as we do for most of our advocacy areas. I think the second one is just the importance, and I really just want to thank Christian again and Total, because if we didn't have, this is why we have these expert forums. And we really encourage those who are indirectly associated with the oil and gas sector, particularly as well, to participate even when there are charges that come with it, because information is power. There are no other platforms where you will find this kind of information, and you use it also as a means of ensuring that you are in good understanding of the developments that are taking place in this sector, and also emergent issues in this sector that affect your primary sector. So just an encouragement for those who are here and for those who have influence in their organizations, including our members. Please show up for these forums. There's a lot of information that comes in just attending just 1 hour, dedicating 1 hour, 2 hours, and it's on global matters, because we don't exist in isolation of what's going on globally. So I'd really encourage you also to look out for other platforms that we provide through the oil and gas sector, because sometimes even when you half listen, you may come out with something that was so unrelated to or you thought was unrelated to your specific sector, but it is on the whole. So that would be my recommendation. And thank you once again, Prof, for being very on point with your response to the questions that have come through. Back to you, Mungai.
Thank you, Ajiko, for those remarks. I wish not to add so much, and thank you, Prof. I can see our time is up, so I'd just like to share one more thing. We have another webinar coming up on the 28th of November at around 3 p.m. Kenyan time. We'll be able to share the flyer to your email, since all of you have registered. And once you receive the link, kindly share across your departments, your friends, family, and even colleagues in different industries, because these webinars are very informative. It will be done by Professor Nicholas Nosjian. He is a senior exploration geoscientist, exploration and production from TotalEnergies, and we look forward to having you guys on the call. So with those few remarks, we'd like to say thank you and have a good afternoon.
Thank you. Thank you very much.
Okay.